I mentioned earlier that correlation should be accomplished with two scale-level variables. But what can we do if we have ordinal or even categorical variables? We do have some options with correlation, and the one that I want to tell you about involves ranked data. Because there are many things that are not possible to quantify, but are possible to rank. Anytime you've seen a top 10 list, you've seen rank ordered data. The 10 best cities to live in, the 40 worst boy bands, the top 100 songs in the nation right now, the best movies. Those rankings aren't quantifying anything. There's nothing underneath them. All we know is that which one finished first, second, third, fourth, what's top of the list, and so forth. But if we have some other kind of data, let's say a list of the best movies along with how much money was spent to make them or how much money was spent to advertise them, well, then we can do a correlation using the ranked data. Another time this becomes important is if we were to have state rankings. So each state in the United States is ranked according to its position on some variable related to quality of life. In fact, that is a data set that we're going to be using for our final in this class. So let me tell you about a second way of doing correlation called Spearman's Row. And that allows us to use ranked data to conduct correlations. The data set that we're going to be using is the one about the world's best liar competition. It consists of 68 contestants and measurements on where they placed in a competition, so first, second, third, etc. There's your ranked data, and a questionnaire that we gave them on creativity with a maximum score of 60. So we're going to use that scale level creativity questionnaire data and see if creativity is somehow predictive of where these people would finish in their competition. Now, the world's best liar competition is a storytelling competition. You have to stand and tell a story, perhaps one that you're making up as you go. Well, would creativity have something to do with your ability to tell such a tall tale? Probably so. Now here's how the correlation would be conducted. And rather than switching over to SPSS, let me simply show you because it works exactly the same as the Pearson's setup. What you would do is move both of your variables into the variables box. So creativity and position and best liar competition both go into the variables box. Now, Pearson is checked by default. You should also add the checkbox for Spearman. Under Options, same as before, choose Means and Standard Deviations, and then Continue and OK. What I'd like you to see in the output is that the Spearman's Row is a better way, or gives us a better estimate of the relationship between these variables. You'll notice that the Pearson correlation is a negative 3.06, and the Spearman's Row is a negative 3.73. So it is a stronger correlation. And why is this correlation negative? Well, think about the meaning of ranked data. Which is the best position to finish in? First place, or 1. So the negative relationship between creativity and ranking really means that the higher your creativity, the greater your creativity, the lower your ranking, or the better the position. The more likely you are to be in first or second place than in fourth or fifth place. So that explains the negative correlation between those two. Now again, the Spearman's correlation is the correlation that you will use when you work on your final and you are using the ranked data for each of the 50 states. And just in case you're curious, the only difference between Spearman and Pearson is that the Spearman's Row ranks the data first and then runs a Pearson correlation. So the actual mathematics are exactly the same. It's just that the correlation, the Pearson's correlation, is being run on previously ranked data.